All right, it's flashing. I think it's working. All right, so we've talked about basic antennas, the last couple of meetings, and like I think the last one we talked about coax, and we specifically did a 2 meter and a 440 loss test. It was a real simple one. We used a radio and we looked at it. We said, okay, this radio hooked to this power supply puts out this much power, and when we put this piece of cable through it into a dummy load that was the same dummy load on every test, we looked at how much we got out of the radio. Then we looked at how much we got through the coax, so we understood, real basic coax loss, and just gave an example of the different cable. So tonight, as promised, who knows what this is? Did anybody know what this is? Quarter wave. That's right. It's a quarter wave. Anybody have an idea what frequency it is? 440. That's exactly right. Does anybody know why we chose 70 centimeters in here tonight? Wait, I heard it. What? Portable. Small. Yeah, and why would we do that? We're indoors, and it'll be less affected by junk around us. Because if it's a 2 meter, the wave's 2 meters. If it's 6 meters, so this is really, really small. So all we did is we took, for those of you who haven't made, how many have not made a quarter wavelength antenna, a little ground plane? You haven't done it. Okay, so what we did, or what I did, I'm not going to say we, I'm going to say I, because I did it. I got a connector out of my junk box, and I grabbed some number 10 solid copper wire, and I soldered it. I don't know why, I just did. You can also use some 440 screws and crimp the ground radials onto here and just screw them on that way. You don't have to get this thing blazing hot for it to solder on there. And the center one, I just tinned the wire and stuck it in there, and boom, there's the driven element. And then does anybody remember the formula? Exactly, 234. So what we did, or what I did, is I just took a piece, I just cut these pretty close to a quarter wavelength long, and I cut this a little bit longer than a quarter wavelength, so I could measure it and I could see what it did. And then just for fun, I put this little, I'm going to put this a little bit closer. I put this little curly Q thing on here, and this is our hokey finoki, I can't believe he did it that stupid, tuning thing, okay? Yeah, that's a tuning thing. So, and we'll take that off in a minute. So the traces that are up there are from earlier, and you'll notice that one trace on there, which is this one, this over here on the far left-hand side is SWR, and as you go along here is frequency. And if you look at the bottom of the chart, 440, which is, kind of not all the way at the bottom of our band, but the bottom of where most of our repeaters and things of that nature pretty much start. And then over here is 450, which is the top of the band. That thing's magically moving. And so I just programmed this thing for a 10 megahertz bandwidth, just to give us an idea. So I swept it, and we'll do it again to see what it looks like, because we moved it. I could hit control. So this thing does it by points. And if you look down the lower, which is data transfer, this thing measures by points, and I have it set for 100 points. So it's going across the 10 megahertz band. It's measuring it 100 times. So when it gets done, it'll say ready, and there you go. There's what it is now.
Curly Q messed it up.
Yep, exactly. And so as we look at that, we're thinking, well, what did we do wrong? Well, the curly Q messed it up. So let's turn the curly Q down a little bit. So I just shortened my antenna, and I'm trying to tune it, and I'm going to go back up here and I'll measure it again. Now, keep in mind, guys, we'll talk about different measuring devices. We'll bring in the MFJ and the Comet, the 500, which is really, it's got analog meters on it, and it goes way faster. I brought this one because we got to put it up on the screen up there, so you could see it. So it's a little bit different. So let's just pull this thing off. Let's see what's going on in here. And we may have messed it up just by moving it over. We'll measure it again. See what it does. and then we'll move it. If you had one of the other boxes that had analog meters, it would read it much, much faster. Oh, look at that. So now we're down in this area here. So we're getting down, you know, and our repeater is, the one in Fairfield is 441.650. So, you know, here's 445. So we're kind of, the transmit would be 441.650. So 446. So we get up in here in the 446 range. We're okay. What is that? So if you look at that little box, it says SWR equals 2, and my return loss is 9.6, which there's a formula that you can convert the two. We gave you that. I gave you that chart 2 months ago that you could look at that. And another thing too is kind of look at the Z, and let's look over here. There's a point to all this, and I'll show it to you. I'll tell you in a second. Let's look at. Oh, we don't want to look at. Let's look at this. I want to look at R actually. Let's look at that. Okay, that's pretty cool. So 50 ohms would be right on that line right there. You see. So we're not at 50 ohms on that last trace that we did. It's off. So we're going to go back to the easy to look at trace. We're going to look at the SWR. That's easy. So we're going to find out that our quarter wave is cut just about right. And when do you think it's off? Does anybody know?
Try bending the grounds 45 degrees.
Anybody but Bruce can answer. No.
Do what Bruce said.
No.
Except not as far.
Do what Bruce said. Let's do that.
Down about 30 degrees.
Let's go about how.
That's about, a little more than that. But
You guys,
there you go.
somebody that's with somebody, tell me what to do.
You're doing it.
Okay, is this far enough?
You're good in there.
Try it. See what-
So let's look and see what that does. Let's measure it, and I could hit control something 9, but by the time I figure that out. So let's let it run again, and we'll see what it does.
People waiting for charts.
People waiting for charts, and boom. Look how much it changed. So now we're operating up here in this range. Now look at our return loss. Our return loss is approaching what? 12, and our SWR is now down in the neighborhood of 1.6. So now we're into the usable range. I wonder what happens if we bend it more.
There's a point to it.
It's a point of no return,
Yeah.
but we'll just monkey with it. Let's see what it does. It's not going to get much better. It won't. It'll change. I just don't remember how much. I think I can get it down to 1.5 if we goof with it.
So gee, if I put a mag mat on a flat roof.
Well, there you go.
But if I have a VW bug that's rounded on the roof.
Right. So here we go. Now we're up at 13, almost 14 return loss. And look at our Z, guys. Where's our Z? 45 to 49. Our complex is 49.2, and our Z, actually our complex is 45, and our Z is 49. And our phase got better too. Everything got better. So, and I isolated it from this. That's why this PVC pipe is here. I just wanted to isolate it from the metal, just so that we could get as close as we could to this thing hanging out in space, you know, and checking it. So, what's that?
Do it more.
Let's do it more. Let's find out.
So when you bend it, are you effectively shortening those?
No. We are changing the feed point impedance. And what it's doing is your maximum energy is transferred when the input impedance matches the output impedance. So when they're straight, it's much closer to, I think it's, 25 ohms? Something like that. And then 25, 30 ohms. So there's going to be an SWR much closer to 2 to 1. So, and as you, here, let's go ahead and just do it while
Is
we're.
this telling us not to use a metal pole?
No. I didn't hook it to this because I wanted to isolate it from the metal pole. Your ground plane is important. If we made that ground plane bigger and better, and it was like maybe 5% more, look at that. Now at the tuned frequency, we are at below 1.5. We're now at 14.25 return loss, and now our Z is 51.3 ohms. You think that antenna would be a pretty good omnidirectional, no gain antenna on 440? And where could we use it from? We could easily use it transmit down here at 445.1, because we still got a return loss of 13.86. Let's go down here.
It's really usable.
It,
It is totally usable with low power.
Yeah.
all the way across.
yeah, what was you saying, Bruce?
Your dip is above 445.
Yes.
Halfway, so if you lengthen that vertical part,
Mm-hmm.
lengthen it, it'll bring your dip.
Let's try it.
Put the thing back on.
Put the thing back
Tuning
on.
thingy.
There's always one smarty pants in the group.
Now, isn't
There he
that
is.
inductive tuning? I mean, wouldn't it be better if
Okay,
the actually touched?
yes, it would be better, but we're just doing it the easy way.
Oh,
We're just inductively coupling it. It's going to change it. Let's see what it does. Look, guys, this is the best way to learn. You set your stuff up at your house, and you just do it, and you find out what it really going to do. Look what it really did. You know what? Yeah, because our ground plane is tuned, right? And then we changed this. You changed it, and it just jacked it up. I don't know. Let's just move it up here. See what it does. And it would be different if we soldered it to it. I'm going to make one with a little, that's a little sliding out of some brass tubing from the hardware store, and I can move the ground radials and the center one up and down. Look at that! It just got horrible. Yep, but works better without it. So we're going to take that out. We're going to do one more little trick, then we'll be done. We'll just pull this back, see where we're at.
So this is a totally stupid question,
Go ahead.
because I don't know at all. So
Okay.
why do we have to have 4 of those ground things? Can we just have one that just?
No, you want a nice uniform ground plane all the way around it, because you're working for an omnidirectional pattern and a nice even. I don't have the right words, but you want everything even for the ground plane. You want everything balanced.
So why not have 6 or 8? What happens if you get?
Oh, if you put more, oh yeah, more.
more's fun.
More is better. If you could put 5 around if they're evenly spaced.
How about a metal cone?
Absolutely.
A discount antenna?
There's a disc cone. Well, chicken wire. We could bring a disc cone in sometime and we'll measure it. You guys will be able to see what it looks like. It's a disc cone antenna is like a unity gain antenna at a whole bunch of frequencies, and it works pretty good. There's a bunch of guys. They'll take a disc cone antenna, stick it up out there, and they use it from really.
Meters to 1.2.
Yeah, exactly. And it works really good. So here we go. We got your typical simple. We made out of scrap parts out of our junk box, and we used intentionally a reasonably short piece of RG8X because that was what was laying around. So now, what have you? Oh, Bruce brought up a really good point about the vehicles. If you had a van top, because a van top or like a 4-door sedan or something that was a nice flat top on it, right? And you stuck your brand new quarter wavelength antenna on top of it, right? For 2 meters, and it's like 17 and some odd inches or 19 inches, whatever it is, I don't remember. And you started trying to trim this thing. And you kept trimming it, and you got it to like 1.6. And you go, man, if I trim a little bit more, it's going to be 1.5. And you go, tink, and it goes up. It didn't go down. What happened?
You get really pissed off.
You get really pissed off and go, why did I do that? You went the wrong, because your ground plane, your feed point impedance wasn't allowing you to look at your meter and go, wow, that's perfect, because the feed point impedance was off. But then you go buy that super cool whatever brand out there that's something with a coil on the bottom of it, which is some kind of matching device that these guys figured out. And it could be an end-fed half wavelength. It could be a 5/8 wave. There's a whole bunch of different things it could be. And people figured it out, and then you adjust that antenna correctly on the same exact ground plane, and you go, oh my goodness, with the same exact cable, it's almost 1-to-1, because they had an impedance matching network at the base of the antenna to compensate for it. And in many instances, and we'll do that maybe next time, or we'll take out the time to, I'll ask you guys just to randomly bring in your magnetic mounts, and we'll measure the cable on it, and I'll bring 2 in. One I know is right, and one I know is different. It's not wrong, it's different. And so, because the cable matters. Okay, so now we look at our last 1.5. Wonder what's going to happen.
So what do we put in here?
We put a 50-foot piece of, this is my 50-foot piece of RG8X that we keep bringing back over and over again. Decent cable, ordered it off of Amazon, I think. And I'm going to put my quarter wavelength antenna on a pole outside so I could talk to all the local repeaters. And I got my new super cool MFJ or somebody antenna analyzer, and that's what I use to adjust my antenna. But I adjusted it with that other piece of cable, and then I stuck this piece of cable on it, and I went, wonder what's happening.
Whoa.
What happened?
It's perfect at our frequency.
Mm-hmm. Look at that. It's right there. It's just beautiful at 145. I mean, look at this thing. You come over here, we're up at 446, which is well above our repeater input, and over here. And look at this. What's this? I have one question for y'all. Do you think coax matters? Do you think a different length of coax of exactly the same kind might change your response?
Yeah.
Do you think if I looked at that and then we did this, we might get an even different reading than we got before because we added all that loss in there? Let's see what it does. I didn't bring the other super low loss coax because I didn't want to spend that much time tonight, but I thought this would be a pretty dramatic difference, and it is. I've never done it with this piece of coax. Look at that. It's still pretty good here, but what's happened is we found somewhere where that dip is somewhere in the groove of our half wavelength multiple down the line, right? We found one, and guess where these are at? Who said that? I figured it had to be Ed. It had to be. I knew it was one or two people. So, yes, that's going to be somewhere. So, when I talk about working with your cables and your antennas and finding your groove, what I mean is at this frequency, let's tune the thing back because this is we tuned it this way, right? So it dumped down to 0. It's almost perfect. That was intentional. So we got the thing almost perfect. Let's get it back.
But if you take the antenna off the coax,
We take the antenna.
you get the.
Well, we can also put a 50. Now we're back. So let's see what the coax looks like by itself today. And that's a whole nother deal. I'm going to bring my calibrated stuff. You ever heard of a calibrated load, a calibrated short, and a calibrated open? We'll bring those, and this machine will help us with that. Let's see what happens when we take it off. It's going to do something weird. Now there's no antenna out there.
So this is getting a reflection.
Shouldn't it just,
Yeah. And then good spots and bad spots.
There we go. So now we just looked at it. So what do we think? What do we think this is? That's a quarter. That's more somewhere along our quarter wavelength multiple. Somewhere over here is what? Closer to a half wavelength multiple. And this right here, right, is awful close to that. So when I put my almost 50 ohm antenna on my almost 50 ohm cable at my almost half wavelength point, I have a groove. I call it a groove, and I'm gonna get hate mail over this, but it's just a spot, a sweet spot that just kind of works, you know, and we get to see it. So there we go. We're gonna let the thing run, and it's gonna come back, and it's gonna shift right back down into that hole with this particular. There it is. So now we can compare the two. So the coax by itself is the one above it, and the one with the 50 ohm load on it is there. Now, if we took a calibrated 50 ohm load and put on there, and we widened our scopes, the bandwidth, so we could see it, we would see the humps. We'd see it like this. Every time it goes up, we're at or close to the quarter wavelength, and every time it goes down, we're at a half wavelength multiple. So if you can, you'd sure like to be somewhere in the half wavelength multiple. Now, if I shorten the cable like we did, right, I got rid of a lot of my resistive losses and a lot of the other stuff going on. This really was more closer to a representation of what that antenna is doing than that is, because I have all that loss in there, all that length of cable. So it kind of tricks me into thinking I'm better than I really am, because we know that piece of cable at 445 megahertz is got loss. There's several dB of loss in that cable. So even though it looks better here, the overall system SWR looks better, but did my antenna get better?
3 dB's half your power.
It's just, exactly. And there's resistance in there, and there's inductance and capacitance. It changed it. So what we could do next time, if you guys are interested, I'll bring maybe next time, we'll see what we can do. This particular machine and others, we could put what's called a calibrated load, 50 ohms, a calibrated open, no connection whatsoever like we did, but it's the way they do it, it's more accurate. Then there's a calibrated short. And this machine will do that. Then what we can do is we go, well, gee, I want to know what that antenna is really doing as if I connected it right to the port, which is kind of hard to do because I'm right here and everything's all kind of bunched up. So I can undo that, do the calibration thing, and at that frequency, that one frequency where it's calibrated, then I can look at that antenna as if it were connected to directly to the port. And it'll compensate for all the abnormalities of the cable at that frequency. That way you can tune your antenna and go, okay, I wanted it. In my case, I was just goofing around. I was shooting for close to 446.150. Where did we wind up? And there's 445. I didn't quite hit my target. But 446 is way over here, actually. 446, I was off. I was much closer to 445. So if I do that and I tune it at 446, right? And then I go get a regular piece of cable and put on there, well, now I'm going to see what that cable's doing, what that antenna is doing, and it's a more realistic reading. Because what I've seen happen before is you can have an antenna out there at end of a 100-foot piece of cable that's really lossy, and your reading looks really good in your shack, but your antenna is not necessarily efficient. So what's the moral of that story? Just because your SWR is 1-to-1 doesn't mean your antenna's good. Anyways, you guys got any questions? Just a little simple thing. Just wanted to slap it up there, and quarter wave antenna, coax matters. That's it.